In this video, let's take our color ramp one step further and investigate what happens when we change the vertex coordinates from world space to object space. We can introduce some simple logic into our graph using the branch node, and then we'll add a boolean to our inspector to allow the user to switch between the different modes. Finally, we'll package everything up in a subgraph for reuse elsewhere. Okay, to start, we can clean up our hierarchy of any objects that we don't need. Delete anything extraneous like this cube from the last lesson. That was just there for visualization. The cylinder you can leave in for now, but maybe it's a little bit easier to see it if we scale it down a little bit. Let's try a Y scale of 10. The current color ramp we've created works in world space mode. If you adjust the origin, where the two colors transition, all the objects using this material undergo that transition at the same Y value in world space. If I drag this origin value around, you can see the sphere and the cylinder change from red to yellow at the same level. Sometimes this is desirable and sometimes not. And that's why if you go to our temp shader graph, in the position node, we have a space dropdown, and that controls the coordinate space of the output. And here we can choose between world space, object space, view space, and tangent space. We're currently using world space, the default, and that gives us the 3D coordinate in the world for each vertex, as you would expect. View space you'll use when you want to output the coordinate position relative to the camera. We'll save that for a future video. And tangent space is used usually when dealing with normal maps or operations that take place along the surface of the model. But today we'll mostly focus on object space as an alternative mode for our position, since that could be useful for our color ramp. If you have a 3D model, each mesh keeps track of its own vertices relative to itself. So let's suppose I have a cube-like mesh like this. Depending on how it was created, usually in an external 3D application, it has the concept of its internal axes, x, y, and z, and it knows where its vertices fall along those axes, and that's object space. If you transform the entire object, shift and rotate it, the world space positions of its vertices change, and that's currently what we're outputting from the position node. But if you look at the vertices in object space, the coordinates don't change relative to the mesh. As far as the vertices in object space are concerned, the mesh could be transformed or untransformed, it doesn't matter. Those coordinates stay the same. So if you switch the position node to object space, the output port is still giving us vertex positions, but it's relative to the mesh's transform. Object space and world space are both useful depending on what context you're talking about. Save the shader graph and let's see how this impacts the rendered material. If you select the sphere or the cylinder and adjust the material's origin, look what happens. First off, the color ramp has changed somewhat. Our origin is currently working in object space now, so our color gradient has changed a little bit. But the biggest difference is that the red and yellow transition does not necessarily happen at the same Y value in the world anymore. Before, when I would tumble the cylinder, you would see the red-yellow transition always stay horizontal with the world. But now, if you tumble the cylinder, the red-yellow transition remains the same relative to the object. This may lead to more predictable results if you want to move the object around in the scene. The colors won't change just because we transform the object. Move or rotate the cylinder, the shader doesn't care. Take a moment and experiment with the spread and the origin and make sure that you understand how they behave in object space. Pause if you need to, just confirm that for yourself. Now when you're ready, let's add some logic to our shader graph. Both world space and object space can be useful depending on how you want the color ramp to affect your object. We can make the graph work in two different modes by using the branch node. You'll find the branch node under Utility, Logic, and you'll see a lot of little logical operators in here. Branch is just one of them. Let's drop that into our graph, and I'll break this connection and then rearrange some nodes. The branch node has a predicate input, and that's a boolean, which is why you see the B in parentheses. And then below that are two inputs for true and false values. Now, depending on whether you pass true or false into the predicate, the branch will output the value that we've plugged into the true or false inputs. By default, it's a 1 for true and a 0 for false. But we don't have to limit ourselves just to a 1 or 0. Because the true and false are input ports, you can connect the results of other graph operations. So in this case, what we can do is pipe a position node set to world space into the true input. Then we can duplicate that node and then switch the space to object space. And then we can output that to the false input. And the branch basically can switch between these two operations depending on what you pass into the predicate. If we pass in true, we'll use the world space position. If we pass in false, we'll use the object space position. Okay, pretty cool. Now to make that useful, I'll need to make a boolean property on the blackboard. So let's call it world space or use world space, something like that. Drop that into the graph and then plug that into the predicate. Connect the branch node back into the rest of the shader graph. And now I'm hoping you can see what comes next. Save the shader graph and let's go back to the editor. Our material gives us a check button that can make the shader graph work in either world space or object space. Uncheck this option and we'll switch to object space. Keep it checked and we go back to world space. This is a handy mechanism just for switching back and forth. Play with that and adjust the spread and the origin as you need to, and verify for yourself that you can switch easily between object space and world space. Then when you're ready, let's head to our challenge. For your mini challenge, let's take the shader graph logic that we've set up over the last couple of lessons and package it as a subgraph. Eventually, we want to be able to incorporate this color ramp into other shader graphs in order for it to be useful. You can convert the color ramp into a subgraph, and you can call it color ramp subgraph, of course. It should be a fairly painless process, but it's always good to have a little practice setting up subgraphs. You shouldn't really notice any substantial change after reorganizing your graphs if you've done it correctly. Think of it as refactoring a shader graph. Okay, pause for a moment, have a whack at it. When you think you've got it, unpause and continue to the end of the lesson. Welcome back. We hope that was a no-brainer. To make a subgraph, simply grab all the relevant nodes. We'll highlight everything that feeds into the albedo of the PBR master. All of this stuff, then right-click, convert to subgraph. Save this asset to disk, color ramp subgraph. Once that saves, you'll see all of the selected nodes collapse into a subgraph node. Unity was smart enough to create the necessary input ports, named for the properties already feeding into what would become the subgraph. Our preview, however, is broken right now. We've reverted to our gray base color. The only thing we need to do to restore the color ramp is just drag out the properties and then pipe them into their respective ports. 5 properties, 5 ports, we just need to connect them. And that should be all we need to do to get everything working again. Once we have that, our color ramp shows up on the albedo. If you want to check out the subgraph, go ahead and double click it. You'll notice that Unity has automatically created properties with matching names, saving you a lot of manual work. Because we already had public properties before we converted to subgraph, Unity knew that it had to create those to match. And making subgraphs like this can save you a lot of bookkeeping. Otherwise, you'll need to create 2 sets of properties manually. Remember that these properties represent the input ports of the subgraph node and don't actually appear in the inspector. So there is a distinction. Our subgraph is a little bit messy because the properties were automatically created and dropped into one place. You can always tidy up manually, save the asset again, then go back to the editor and just verify that everything is working and looks exactly the same as it did. We have a shader that lerps the color either in world space or in object space, depending on your setting. And we've packaged up the relevant shader logic into a subgraph, which will be handy later. In the next video, let's incorporate this back into the force field shader graph, and we'll see how the color ramp can be applied to the original shader.